Hello all, I'm Alin, the platform lead at Wisecube, and in today's presentation we will cover AI observability tool built by Wisecube in conjunction with Databricks. Second, so I want to present also the Wisecube team that it was founded in 2016 in Seattle as a team of AI and data experts. And this is our team, like founder and CTO Vishnu, then Alex Thomas, the principal data scientist, head of product Alexei, me, and Zakaria, the head of AI. Our solution was pretty much based for the semantic discovery as a semantic discovery platform for highly regulated industries like chemical, pharma, healthcare. And here we can identify our partners. What we will cover in our today presentation, it's like the problem with monitoring in generative AI in an AI system. And monitoring generative AI system, it's in a way crucial because we need to ensure that they operate ethically, accurately, and safely. However, there are several challenges that arise during this process. And here are the challenges that we identify as important one in the generative AI system. And uh, they are as following: the bias detection and mitigation, that is a common problem, and that it's inherent and somehow like amplifies biases from the training data. Content appropriateness. So this is like that AI can generate inappropriate or harmful content like hate speech, misinformation, explicit material, false positive and negatives. This is like incorrectly flag for the content. It can or miss harmful content, so it can give incorrect results based on the training data, based on the data that it was trained for on the model used behind. Then it's also the scalability as a very important challenge, because as the volume of the data it's growing, the AI can generate a lot of content, and we don't know exactly how trustful it is. And basically, to to do that, we need to increase exponentially the scalability of the system. And scaling for this part of monitoring system to handle these vast amounts of data in real time without, let's say, significant delays or resource consumption, it's very difficult. That's why we have done all this part in conjunction with Databricks to see exactly how everything will work inside the lakehouse. The dynamic nature of the AI. So this is one of the challenges, because the generative AI models are continuously updated and then can evolve their outputs based on new data. And we need, in a way, to adapt quickly to these changes, which can be resource intensive and also technically challenging. And the last one, interpretability and transparency. This part, it's like related to the AI decisions and outputs that can be make them hard to understand why a particular piece of content was generated by an AI system. And to cover this specific case, we need to adapt and ensure transparency, interoperability in monitoring system, so that decisions of an AI system can be explained and justified in an ongoing issue. Okay. So monitoring in generative AI, as I mentioned first, it's very crucial in order to ensure that they operate ethically, accurately, and safely. So to explain a little bit these points here, it's like the ethical and privacy concerns. It's monitoring may breach privacy. So monitoring in generative AI can involve analyzing vast amounts of user data and can raise, in a way, privacy concerns. So the challenge in this case is like, to balance the effective monitoring with respecting user privacy. We need to take care of data protections and regulation that becomes a very delicate task in most of the cases. Another important aspect is the real-time monitoring. So this can be the problem in this case can be that it can be harmful content, the harmful content that can spread quickly, that requires, let's say, immediate intervention. And in this case, we would need technically, we need to develop systems that are capable of doing that real-time monitoring quickly, accurate, and to respond as soon as possible to the detected issues. And as last 2 points here is the cost and the resource, because the effective monitoring requires significant computation resources and expertise. As let's say that smaller organization or less well-funded projects may struggle to implement robust monitoring system, because in some edge cases it can take a lot of resources to deploy a system, or to use a system that requires a lot of power that needs to be consumed in order to generate results. And then are the adversarial attacks, that AI in a way can be manipulated. And to avoid these issues, so generative AI can be targeted in a way by adversarial attacks that are designed to trick monitoring system or to exploit model weakness. And in this case, we have to build a resilient monitoring system that can detect and respond to such attacks without overburdening the resources. So in a way, we need to build something that we can rely on it, and we can identify problems easy, and the resources are not used based on a hacking or someone that is altering the AI model. So addressing these challenges requires a multifaceted approach, combining technical innovations, policy development, and also collaboration across all the stakeholders of the model building, of the interaction with the external AI tools, external AI systems, or anything that can interact with the monitoring of a given lakehouse, as we will explore later in our demo session in Databricks. Okay, then why do we need Pythia in monitoring? Pythia is a tool that was built inside Wisecube exactly for exposing and detecting issues with AI responses and detections based on in the knowledge graph, and based on information that it can pick up and detect externally. So why Pythia? Because compliance is no longer a hurdle, but a seamless aspect of your AI operations. Integration with Databricks monitoring and reporting, it's not only helping you track and document your application AI performance, but also in a way helps you to get a standard, and also of accountability, and also transparency of all the AI responses and results that you have that you get from all the questions that were done against an AI system. And basically, Pythia will try to detect hallucinations, and in this case, we see that hallucinations refers to instances where AI systems, particularly language models, generate outputs that are inconsistent, nonsensical, or even entirely fabricated. So that's why Pythia is in the middle. We'll try to detect exactly all that particular issues, and we'll try to give you a percentage accuracy, how far the result is close to the reality. And in this case, we see that hallucination rate of leading elements is up to 27%, then stock impact 5 to 10%, and also the healthcare misdiagnosis and also legal errors, we see the impact that we have right now. And how do we do that? Reducing of the RAG hallucinations. RAG is not a silver bullet and cannot completely eliminate hallucinations, but in conjunction with Pythia, it can enhance the information filter improve the context, and also extract and categorize the claims from the LLM responses. And the most important part is that it uses knowledge graph in LLM that it's specific based to each domain that it's searching for results. Okay, what are the Pythia benefits? It's like enhanced accuracy. It's offering like a real-time detection of AI hallucinations and ensure the accuracy of AI outputs. It is scalable. It can be easily integrated into existing workflow. It can scale across multiple and different applications in the system, and it is completely agnostic of the operating system or services that are or cloud providers. Reliability, it's like continuous monitoring that can be built around Pythia or using Pythia into your AI system. Then it has the compliance, so it helps to maintain regulatory standards about robust reporting and monitoring. It is cost efficiency because whenever it is integrated, it's only called when it is needed, and that's why it can be used only if you need to check LLM responses and results. And it's data-driven insight. It has a knowledge graph integration that can provide contextually rich and factually accurate insights. So that is the most important part of Pythia benefits. Here is the architecture, how all these things of Pythia is integrated and how it works. And it's an AI client application that basically can have like an LLM that's calling something in the backend. Then Pythia will extract the triples. Then we have a checker module, and the checker module will go then to the knowledge graph to identify the triples from the graph, and then basically Pythia will categorize all the triples that were detected, and this metrics will be provided to the monitoring alerting system, and then the operator can see and validate the output response based on the accuracy that was provided by Pythia. And now I want to start how Pythia can be integrated in Databricks and how helpful it is to have a tool like Pythia in Databricks. Okay, Pythia, it's compliant, and it's made effortless to be integrated in any system and any cloud provider. That's why it's a seamless compliance integration. So with Pythia, compliance is no longer a hurdle, but a seamless aspect of your AI operations, because it can be integrated as a simple pip install, and you have the Pythia available, and you can use it. So, and the Databricks monitoring and reporting, it's offering you like the UI tool. In them you can see and investigate and creating dashboards and prepare all the monitoring tools and UI visualizations that you want, like dashboards and stuff. Okay, one of the, let's say, 5 important aspects to monitor in generative AI are like the metrics. In them you want to see like the response time, accuracy, and efficiency. Then the bias and the fairness. So this one in a way and ensure that outputs are free from bias and promote fairness. And in that case, you want to avoid to get like false positive information from the LLM. Data privacy and security. Monitor data handling in a way. We would like to protect user privacy and secure sensitive information. So with the monitoring through Databricks, this is possible that the data is protected and secure into a cloud environment. Compliance and accountability. So this one, it's our regulatory standards, and in a way they are trying to expose transparency on the information that that was processed and exposed then through Pythia into results into a Databricks table, and then model-driven adaptation. So we would detect and adjust to changes in model behavior, or in a way like to see exactly how it will perform over time based on the decisions that were made on the good results, on the positive results that have come with high accuracy, and on the one that were like negatives and they were like completely wrong to what we expected from the LLM. And here are like steps. In them, I want to present how Pythia can be integrated and used in Databricks. And everything starts from an inference table and the service point. So this is happening in Databricks. Then it's a requirement to install the Pythia library. Then all the information that is coming from Pythia of the LLM analysis will then be stored into tables, including also validators that are coming out of the box from Pythia. And the last step is to create data dashboards using Databricks monitoring section. Okay, here is the complete architecture of how Pythia is integrated and how all the things are tied together in Databricks. Like, as I explained before, like section 1 with inference table and Databricks model in the model serving layer. Then we have the data warehouse with the Pythia table, then Pythia rows that are written directly from Pythia, and also the rows that were created from the LLM responses that are coming from the inference table. So we have Pythia from Wisecube that it's getting data from the LLM and then exposing the results into another inference table, and that will completely reside in the data warehouse. And the last part is the dashboard. Oh, 1 second. The dashboard, in them, we can see the metrics, we can create and customize our own dashboards by using the Lakehouse monitoring part. And in the next section, I will present like the notebooks demo that I created in Databricks, and what we would check here is like we would have a notebook that create sample data for inference table, then the table schema for Pythia hallucination, and the last step is the dashboard for monitoring and alerting, and how to configure that aspect. Okay, and as we see here, like these are the key concepts in a way, and what is the purpose and functionality for each independent notebook. And starting with the inference tables. The inference tables will store and manage AI predictions. And the functionality, it's like to have a centralized data collection for everything that happens into the LLM and model responses. Then we have the Pythia with validators that will validate quality and compliance of the data, and all this information will then be stored into Databricks tables that will be used as monitoring that will serve the monitoring dashboard. And the monitoring dashboard will track the AI performance and compliance, and in them we will see like metrics, and we can ensure the operational health of the system, of the AI system and the models. Okay, now I will jump to the demo. I will share the screen, and here we have the first notebook. In them we will create some records for the inference table, and for that we are using like a custom prompt that using like a question, and the only thing is like the workspace needs to have like the Unity catalog enabled, and needs to have a Databricks serving serving layer that it's used as a model to make sure that you can get the results exactly as Databricks expose them, because there is like a internal structure that is created for each response that is coming from the LLM. Okay, let's go back. Okay, so this function here, it's only to populate exactly what a default LLM will do in Databricks. So it will do a request. It will do what we have here is like some sample data that it's calling the exposed model deployed in Databricks through the serving layer. And what we have is like the API key of the serving layer. We have the model based directly from the serving endpoints and the model name. 1 second. And as you have seen, the model, it's exactly here, the Pythia serving model. This is used exactly, and it's ready. And it's a Llama v32 based model that was used, the 1 billion one. Okay, let's go back. Okay, so we have here some sample questions. We have a prompt, and we use like OpenAI and the personal access token for that. If you want to use OpenAI, if not, you can use directly that model. So we have also that possibility that you can use a client and call directly with an API key and get the same results from external model. Then this is the function that it's called inside Databricks for do the completion and ask us the questions, the template questions. And basically, in the end, all this information will be stored into the inference table. And the information in the inference table. 1 second. Information in inference table will look something like, I will bring another screen here because I have here a screenshot. Okay. Okay, so information will look like that. So we'll have like the request, the response that it's coming from so it's like timing, request, and response. So this is what we would get from an inference table. So this is the schema that it's like the inference test payload table that will reside in Databricks in the data warehouse. Okay, so right now we have the table populated with requests and responses from the serving endpoint. We will move to step number 2. It's like Pythia table from inference table. So this function retrieves values from Databricks widgets, as we have here defined them, and basically what we would need to provide is like a Databricks token that can be obtained like from settings, developer, and access tokens as access tokens for the model. Then it's like a catalog. It's the database from where we have the delta table and the inference table stored. The model-based URL, the one that it's used also for the serving endpoints. And in this case, as you see, like we are using a internal Databricks, the Mixtral 87 billion model, a completely different model than the one that we have used for creating the responses. And then we have the Pythia schema. It's like this table name as Pythia serving payload, the table name, the table name, and the refresh interval. So how often do you want to refresh that and to check that information? And basically we can set that, as you see here, like all, daily, hourly. So this is like all integrated into this Pythia method. First step is to install Pythia. with pip install, it's like it will install all the time the latest available version that works. Then to restart the Python kernel to make sure that everything it's up to date, and then basically to use the Pythia, the hosted model, and the Pythia v1, the evaluator, and then with all the information from the widgets and the parameters, we then create. Here is the refresh interval, how it was implemented, and the SQL query to retrieve data from the inference table, and then the LLM has written all the requests and responses. And here we have the question context from request. So here is the request data that has come from Pythia. From the LLM, and this will be like split it in question and context for calling the model with Pythia. And basically, here is the model response, the method that is taking care of the model response, and then it's the Pythia integration. And basically, here we have like the hosted model by using the API key and the URL of the Databricks model, and we are taking in consideration the response and the request. And basically, after sending this information from the inference table, from the row table through Pythia, we would get a response back. In them, we would get like all these metrics like accuracy, entailment, contradiction, or neutral. So we have this information back from Pythia, and basically this is how it will look like in the table. We will have like a client request ID, a Databricks request ID, the date when it has run, like how the timestamp in milliseconds, and a request that was made. Like this was the request, and this is like a response time from this table. Okay, and if we take a look at the inference and the inference table, what we had to do is like to create like an internal structure that it's converting the data frame that it's obtained from Pythia into the same structure as the monitoring table that it's serving the Databricks dashboards are requesting to be in a default template. And this is the default template that we had to create in order to make sure that everything respects and the information can be picked up in the dashboard. And as we can see here, based on the Databricks request ID as we have previously, we get for each request that was previously exposed into the inference tables. So initial inference tables, you see you have a Databricks request ID and the request and response. We get Databricks request ID as a relation between that two tables, and accuracy of the response, if it was an entailment, contradiction, or neutral. And basically also what the validators have done, and what was like, we have like 6 validators that are completely integrated, 7, because we have 7 here that were completely integrated, and we see exactly if we have like error message or if something is wrong with the message, with the information, the response that was detected by the LLM. And here are all the informations. So basically, after we have that data frame, we can write it to our inference table as a delta table, and all the time it will append and will add new data to the table. And the last step, it's like to create the time series monitor. And 1 second. So So this is setting up like monitoring for a delta table in that Databricks, and this somehow like ensures that we can have like time series data qual checks with specified granularity, and basically the delta table monitor function creates a quality monitor for specific delta table. So with that simple information here, we have like a monitoring delta table that it's created in Databricks. And 1 second. I want to go to the last part. Yeah, and this is like 1 second. Yes, and basically we can have with these 3 simple steps all the complete integration of Pythia in Databricks, and monitor and see all the metrics. And I will show you right now how this will look like, because we have here also the GitHub project that was created based on a Databricks template with notebooks integrations and steps how to integrate everything. And 1 second. Yeah, this is the dashboard template that can be created based on the inference table. And these are some stats that we can get, simple stats that we can get from the Pythia information, Pythia results that were stored into the inference table. Like we can get accuracy, statistics with min and max, and all that information. So there are like complex integrations that can be done with the data, and can be automatical and connected to a dashboard. Okay, so thank you, and hope that I made myself clear on all the steps that I presented. Okay, thank you all for paying attention till the end. And now we are on the Q&A live session. So, and one of the questions that has popped up was like, how can integrating Pythia with Databricks Lakehouse Monitoring mitigate the risk and detect hallucination in real time? So, because the mechanism that it's created inside Pythia, it includes an integrated knowledge graph, which with the aid of the validators can expose and provide numerous valuable insights. And in this case, this will ensure that reliability and also accuracy of the machine learning models that are used internally in Databricks can give real-time data processing in the Databricks environment by using Pythia. Okay, please, next question. Okay, very important question, like if training is included for customer who buy your product. Yes, so we have a lot of documentation around that, how to build that part, how to integrate that part, and also training data for the models, and also how to use the models, so how the models were prepared internally to create all the accuracy, entailments, neutrals, and contradictions that are exposed by Pythia. And most of this information can be also found out in our blog post that we have exposed publicly on our website. Next question, please. If Pythia adds more latency to the responses, I can respond with yes. It depends on the type of the request and response that it's coming from the LLM, but for sure this will add latency because primarily due to its utilization in a way, it's using a comprehensive knowledge graph, and also it incorporate external information that was cleaned up and it's used internally in the models to ensure the accurate and contextually relevant outputs. So the added latency, in a way, it's a trade-off for enhanced precision and reliability for the LLM responses. So as the system, in a way, processed and validates that information from various sources, you will get, like, before generating the final response, you will get like a real value. So basically the latency will come with a better accuracy. Okay, and yeah, the last question that was added here on the poll, like what are the key challenges in implementing the chain pool based metrics for evaluating the quality of LLM outputs, and how can this be addressed to ensure reliable AI application deployment at scale? So in this case, I see like uh, more challenges, like key challenges, like the one of it would be like the contextual understanding, then data quality. So to make sure that, yeah, the accuracy of the AI models, it's heavily rely on the quality of the training data. Then it's the model architecture and how the design and how it was like trained and what was the objectives of the AI models. uh, we need to think and also of computational cost, if we want to have the data like real time or like hourly based, or every day, every week. So this will bring like computational cost. And the yeah another important aspect is like integration with existing systems in a way. So like how you can integrate Pythia with a simple pip install and attach it to whatever model, whatever notebook you want to create around different models. So it's very easy to integrate, and this will somehow, like, yeah, you don't need to have any planning or any a hard configuration that you need to include into your architecture. So I think that I cover most of the key challenges in this. Okay, thank you all, and hope that it was a nice presentation for you to get in touch with LLM monitoring.